8.1, question number 20, parametric equations. I think we're just graphing, right? Is that what the instructions are? So I want a column for t, for x, and for y. Whoa, that line was not straight at all. Not that it had to be, but it was really bad. Here, I'll just do this. Makes me happy when everything lines up right. Okay, so t. So we need to pick values for t between 0 and pi. Remember, it's just fine to use degrees if you'd rather. Just make sure your calculator is in the correct mode to do that. All right, so I'm going to start with 0. So negative 2 times the cosine of 0. Well, the cosine of 0 is 1. So negative 2 times 1 is negative 2. And then the sine of 0 is 0. So 0 times 6 is 0. All right, I don't know how many points we're going to need to make this make sense, but we're only going to pi, so that's not terrible if we just kind of do all of our major angles. So if we do a pi 6, let's see, cosine of pi 6 is square root of 3 over 2, multiply by that by negative 2, and we get negative square root of 3. Isn't that like a negative 1.7? Am I remembering that root approximation correctly? And then sine of pi 6 is 1/2, so 6 times 1/2 is 3. Then if we do pi 4, we would have negative 2 times square root of 2 over 2, so that would be negative square root of 2, which, is that 1.4? I think. You guys aren't verifying, so I hope I'm right. I'm just going from memory. So then the sine is square root of 2 over 2, so that would be 2 goes into 6 3 times, so 3 square root 2. I need someone to calculate a decimal for me for that one. All right, going to decimal for 3 square root 2. 4.2. Okay. Let's see. I don't know. Maybe as we go. Sorry, I'm suddenly getting a ton of emails and I'm not sure why, and it's distracting me. All right. I think my 9th grade son's English teacher is grading stuff, and so I get an email every time she puts a grading canvas. All right, pi thirds. So let's see. We have 1/2 for cosine, so negative 2 times 1/2 is negative 1. And sine is square root of 3 over 2, so 2 into 6 is 3, so that would be 3 square root 3. Okay, calculate that one for me, Adrian. Okay. All right, pi halves should be easy. Cosine of pi halves is 0, so that's 0. Sine of pi halves is 1, so that's 6. Then we need a whole nother like chart to keep going because I did probably too many numbers, but if there's such a thing. Shrink that a little. Okay, so x, y, I forgot t. Let's make some more plugins here. Doobie doobie doo. Okay. So going to 2 pi thirds. So 2 pi thirds, the interesting thing about second quadrant is that the sine values are going to repeat, but the cosine values are going to switch to the opposite. So the cosine values were all negative here, but they're all going to be positive because it's going to be a negative times a negative. So 2 pi thirds, instead of being negative 1 for cosine, it should be positive 1, right? We should just be able to use these answers. But then the sine would be the same exact one because sine is still positive in the second quadrant. And then 3 pi fourths would be positive 1.4 and positive 4.2. And then 5 pi 6 would be positive 1.7 and positive 3. And then pi, which is included, would be positive 2 and 0. So double check, make sure you agree with my decision those. So we need negative and positive x values, but we only need positive y values. So when I draw my axes in my graph, I'm going to make it mostly, who knows, we will see. Or like half of a circle or half of an ellipse, maybe. All right, here we go. So at -2, we have 0. Here, I'm going to count by 2s. So I'm going to say -2 is right here. So there's a point right there. And then -1.7 up 3. Oh, we can't count by 2s because we have to go clear to 6. Unless we don't count by 2s this way, but we do that way. Would you prefer to keep the scales the same? Are we good with it? So let's say 2, 4, 8, 10, 12. Actually, we have room to go by 2s. We're good. 2, 2, 2, 2, 2. We can, it's still going to work. We're fine. 1, 2, 3, 4, 5, 6. So that would be 6 right there. That's as high as we need to go. All right, so -1.7, +3 would be here. And then -1.4 and 4.2. So in there somewhere. And then -1, 5.2 would be like there somewhere. And then we have 0, 6. And then we have 1, 5.2. So these are just going to be symmetric. So just copy over my approximate dots. And then 2, 0 here. And it ends there. So yeah, it kind of looks like a parabola. It could be half of an ellipse, or I'm guessing half of an ellipse would be a better way to describe it. But half of an ellipse ends up being a bit of a parabolic shape. I'm not going to draw the lines in there because I feel like I would ruin it if I did. I'm just going to connect it a piece at a time. A little bit. We just don't worry as much about the orientation when we get rid of it. Or you just have to use it by doing domain and range. Like instead of having t in it, you would change it to x is from -2 to 2, and so it's going in that order, I think. And then y would be, but y doesn't help, right? Because y is, it's going up and then it's going down. So anyway, that's a good question. Hopefully we'll get to that later if it matters. Okay, so with that, do we still need help with 25? Still want